Good morning, class. So for today, you have we will have the sample problem for how to construct the topographic map of the given elevation. Okay, so for this problem, we'll have uh, construct the topographic map of the given elevation of each grid. So you have the given elevation of each grid. This is done using profile leveling, so you can determine the elevation of each grid, and then use contour interval of 1 meter. So meaning you have a contour interval next to this given elevation. So for example, you have 101.2, so the next interval should be a whole number. Next to this 101.2 is 102. Then you have the contour interval of 1 meter, so therefore you have next to 103, 104, and then 105, and last is 106. Then you have 106.8. Okay, when you continue, you have 107, then 108, 109, and then 110. Okay, so that is how you solve, or how you interpret the contour interval of 1 meter. Then use estimation method. So what I have done here is the estimation method, but I will discuss also how to compute using the similar triangle. And then you have the index contour will be at every 5 meters. So for example, you have this contour lines. So at this line, you have the 5 meter interval. So you have the index contour, meaning the big lines. So in every 5 meters, for example, 5 meters, you have bigger lines. Sometimes in the contour lines, you don't need to input the elevations. So just have the index contour. So for example, the index contour here is 5 meters. So when you see the bold lines or the bigger lines than this contour lines, so in this is a minor interval, and this is the major interval. So that is the index contour. Then the contour interval is 1, that is the minor interval. So this is by 5 meters, this is by 1 meter. Okay, so the map has 8 by 8 grid box. So 8 by 8, this is used when we compute our similar triangle. So to solve for the distance in between the grid box, since in our grid box this is this is 8 by 8. Okay, so this is 8 by 8. Then this one. You have this distance 8 meters by 8 meters. Okay, so we will use this distance when we solve for the distance in between the contour intervals. Okay, so let's have the computation, but in this problem we will use estimation, but I will discuss first how to compute the distance in between interval using a similar triangle. So for similar triangle, for example, you have this elevation. For example, this is A, this is elevation A. then elevation B. Okay, so for elevation A, that is 101.2, and then elevation B is 106.8. Okay, and then you establish the interval. So next to 101.2 is 102. Okay, you have 102. Next is this one, 103. The next 104. The next 105. Then last 106. So next 106 is 108 106.8. Okay, so this is just same as a triangle. Okay, so you need to solve this elevation, that is 106.8 minus 101.2, so you have 5.6. Okay, so to solve for distances, you have this distance. Okay, this distance. This is x1, x2, x3, x4, x5, and this is 8 meters. Okay, so this line is 8 meters, this one. Okay, so to solve for x1, solve x1. Okay, to solve for x1, you just have to have the triangle, this one. This triangle, similar triangle to this triangle. Okay, so to solve for x1, you have x1 is to this height, h1. Example, h1 is equal to 8. You have this distance divided by 5/6. Okay, this height. This is just similar triangle. So you have here the horizontal, you have x1 over the height, and then you have 8 over the height, similar triangle. This triangle, small triangle, and this big triangle. So therefore, you have your x1 over your h1 is 102 minus 101.2 is equal to 8 over 5.6. So your x1 is equal to 8 times 0.8 over 5.6. So you have your x1 is equal to 8 times 0.8 divided by 5.6 is 1.14 meters. So you have now your x1. Okay, so you measure that distance from here to here using your ruler or metric scale. Use a distance of 1.14. So that is your elevation 102. Okay, so next you have, for example, you solve for x5. Solving for x5, solve x5 over this height. Okay, this height, that is 106 minus 101.2 is equal to 8 over 5.6. Okay, so you have x5 is equal to 8 times 4.8. Okay, 106 minus 1 whole. Okay, 4.8 over 5.6. So x5, that is 6.86. Okay, so you measure now again, from this point to this point. You have 6.86. So this is your 106 elevation. Okay, that is how to solve the distances using the similar triangle. This is the approximate the correct method in solving the distance in between the elevation of your topographic map. Okay, so for estimation, so we'll use estimation method. We'll have to indicate the elevation at each grid box. Okay, so let's have the estimation method. So first you have this, maybe we'll have blue, then let's have a green. Okay, so for our interval, we'll have next to 101 you have 102, and then 103, 104, 105, 106. Okay, so 106.8. Next to that is 107, 108, 109, 110. So just an estimation. So you have the elevation in between the elevation at the grids. Okay, so what are the elevations in between this grid with a contour interval of 1 meter? So you have 1 meter in each interval, so in between. Okay, so next we'll have this one. Next is 102, then 103. Okay, this one 102, 103, 104, then 105. Okay, then next 105. So next to 105, so you have 106, 107, 108. So you have 106, and then 107. So this is an estimation part, so, or estimation method. So maybe you can estimate the distance in between the elevation grid. Okay, next is 108. Okay, so next we'll have this line. So from 105 you down to 102, so therefore that is 105.1. So next to that, going down, that is 105. Okay, 105. So okay, since that is 105 and then you have 102 elevation, so you go down. So from 105.1 you go down, so that is 105. Okay, so next is 104, then 103, then 102. Okay, so next this line, from 102 you go up to 106. So next to 102 is 103. Okay, so this one is 103, 104, 105, then 106. Okay, so next is this line. So that is from 108, this one 108, go up to 110. So you have 2 points, 109, then 110. Okay, so 109 and then 110. So next, let's have this line. So you have here 102 to 108. So next to 102 is going up, so that is 103, 103, 104, 105, 106, 106, 107, then 108. Okay, so as you can see, the distance is not as accurate as to this solution to have your topographic map or contours very accurate. So since this is estimation method, so you just have to input the interval in between the elevation grid. Okay, so let's have another line, this one. So you have here 108 and 109.3. So the elevation in between is just 109. Okay, so you have here maybe at this point you have 109. Okay, and then next you have this line 109 to 111.7. So you have 2 points. Next to 109 is 110, and then you have 111. Okay, Next, we'll have this line that is 102 to 109. So going up, so next to that point or elevation is 103. 103, 104, 105, 106, 107, 107, 108, and then 109. Okay, then you have the last line that is 108.4 to 111.7. So therefore that is going up, so next 108.4, that is 109. Okay, this is 109, and then 110, and then 111. So you already have the elevation in between grids. So now we'll have to create or to draw the contours. So to draw the contours, let's have this as yellow, I think orange. And then for this one, we'll have purple. Okay, so contour interval. So at every 5 meters, you have an index contour. Okay, so to draw the contour, you have to use a free hand. Okay, so for the index contour, since we have the 101 elevation or 100 elevation, let's have a 5-meter interval. So for our index contour, let's have the 105 and 110 elevation for our index contour. So to connect, you have here, so you connect the the 2 points with the same elevation. So for example, this one, and then for contour, index contour, you have the big lines. Okay, you connect. Okay, and then you have by the way, this is 106, no? Six. Okay. So you just connect the same elevation. So this one, so if you doubt to connect the same elevation, so you just draft the drawing of your contour. Okay, so for draft, you have to connect first all the points with the same elevation. This is index contour. Okay, so this one is continue to this line. Okay, and also this one, maybe if you have another box here or another grid box, you have to continue this elevation or the contour lines. Okay, so continue. The let's have the contour lines with the same elevation. Okay, so for 102, that is just 1 point elevation, so just leave it as is, since you don't have any 102 elevation. So you cannot cross the line to connect that two elevations, since for contour lines won't cross itself. Okay, do not intersect. So contour lines do not intersect. So for this elevation, just leave it as is. Okay, to continue, let's have 104. Okay, and then this one for next, that is 105. Okay, okay, so maybe this part is wrong. Okay, so since we connect the lines, or maybe this is this one. Okay, so our contour lines here is wrong, so we will have to correct it. So maybe the contour lines here, okay, so the contour lines here, example, this is 105. The contour lines here is going this way, this one, and then this one. Okay, so that is the correct contour. And maybe also for this one. Okay, so for first, that is just a preliminary contour drawing, so we will correct that. So maybe the contour is this one, will be this one for 103. For 102 is this one. Okay, that one. And then 104. So we'll have the freehand sketch for the contour lines. Then you have the index contour. See to it that all the same elevation should connect. Then 106. Okay, 107. So maybe this contour lines is correct. 108, this one. And then 109. So as what I have said, maybe for another grid box, we will continue here and then go through the same elevation, 109, this one. Then 110, you have the index contour, this one. Continue, this one. Okay, and then last is 111. Okay, so this is now your topographic map. Okay, this is now the topographic map of your 8x8 grid survey. So from the given elevation at its grid point, you can create the contour or the topographic map of the area, so you can determine how steep the area or how mountainous the area. So if ever you have the very small distance in between contour lines, so meaning that is steep area. Okay, if you have this area with a very large distance in between contour lines, so maybe this is a plain area or surface. Okay, so topographic map it is usually used for, you have the military map, so that they will know the terrain of the mountain. Okay, so this is the last topic for our CE261, or element that is principles of surveying 1. Okay,